we're going to factor by the greatest common factor. So if you did the even ones, then make sure you put them on my desk some point in time. Okay. So if you remember, we did the distributive property, which says that if I multiply A times the quantity B plus C, I get AB plus AC. So what we're going to be doing today is we're going to go backwards. Okay? So we're going to, where we use the distributive property, we're going to undistribute. Okay? All right, when we talk about factoring. And with factoring, the first thing we always look for when we're factoring is the greatest common factor, because if we can take that out, it makes things a lot easier. And we're going to be doing, with all the multiplying you did on Friday and over the weekend, we're going to, most of those we will go backwards on them. Not all of them. The more complicated ones we won't, but most of them we will. So, all right. So we want to factor 2x squared minus 4 using the greatest common factor. So the first thing, one of the ideas for doing this is if you don't see them right away, okay, which not everybody does, would be to write the prime factorization. Okay? So if I take 2x squared and minus 4, and I do the prime factorization of them, so for 2x squared, that's equal to 2 times x, right? Okay. And 4 is 2 times 2. And when we talk about factoring the greatest common factor, we find out, okay, what do they have in common? Right? What do these two have in common? Okay, they have a 2, all right? So we have a 2 in common. So we're going to put the 2 goes in front of the parenthesis. Okay, all of the greatest common factors are going to go in front of the parenthesis, and then I'm going to put parentheses there. Now, what goes inside is what's left. So we've got x squared here, and 2 left here. Now, what goes between them is whatever this sign is. So we have x squared minus 2. Because now if I multiply that out, I'd get 2x squared, and 2 times negative 2 is negative 4. So if we write the prime factorization first, look and see what do they have in common, goes in front of the parentheses, and what's left goes inside the parentheses then. Okay, let's look at another one. All right. Writing math, aligning common factors can help you find the greatest common factor. All right. So here we have 3 terms. 8x cubed minus 4x squared minus 16x. So when we factor the greatest common factor, we're looking for the largest number that goes in all those numbers, okay, and the largest variables that they have in common, okay, or the largest exponent they have in common. All right. So let's just talk our way through this one first, and then we'll look at the prime factorization also. Okay, I'm going to do it both ways. All right. 8, 4, and 16. Let's just look at the coefficients. All right. What's the biggest number that goes in 8, 4, and 16? Okay, 4 does, right? 4 goes in all of them. Okay, so we have a 4. Okay, now look at all the variables. We have x cubed, x squared, and x. What's the largest variable term that they all have in common? Okay, so we have degree 3 degree 2, and degree 1, right? So the largest they all have in common is degree 1. So our greatest common factor would be 4x. Like I said, I'm going to do it this way, but then we're going to go through it, okay, the other way, right? So it's, what do I have left then, right? And we were talking about unmultiplying is dividing, right? So basically we're going to divide now, okay? What's 8 divided by 4? 2. Okay, so we have a 2 here. And since this is x cubed, and I have x to the first power, I need x to the second power, x squared. All right, and the symbol between them is a minus sign. Okay, so then we do 4 divided by 4 is 1. Okay, and then I have an x squared and x, so I need an x, so it'll be 1x. So you can put the 1 there, you don't have to put the 1 there, you can just put an x there. Okay, so minus x. Then it's a minus sign again. And 16 divided by 4 is 4. And that's just x to the first power. I already have that, so there's my answer. All right, but let's look at it with the prime factorization. All right, so if I factor all 3 of them, write the prime factorization for all 3 of them. All right. So the prime factorization of 8x cubed is 2 times 2 times 2 times x times x times x. Prime factorization for 4x squared, 2 times 2, and then multiply that by x times x. And then 16x, we have 4 2's and x. So notice what we've done here is we've written all the numbers first, then the variables, and we've kind of separated so that we can line up all the like terms, okay, all the things that are alike. And we can see that they all have 2 2's and they all have a single x. Right. So that's my greatest common factor. 2 times 2 times x, okay, 4x squared. My greatest common factor. Or 4x, excuse me. Okay. 4x is the greatest common factor. All right. So, we put the 4x out front. That's right. Okay. I don't like that. Okay. So we put the 4x out front. And then we have, what do we have left? Right? So we have left, we have a 2 and x times x. So 2x squared. Then we have just an x left. And then we have 2 times 2. Right? So we can see them here then. We have 2x squared minus x minus 4 left in the parentheses, just like we came up with. Right? So if you do it whichever way you like. All right. For some of you, you're going to have to do write out the prime factorization and do it for a while. Okay, and that's okay. Right? Because if that works for you, then that's good. Right? So we write the terms as products using the greatest common factor, and then we use the distributive property. Right? So, all right, and then it's never a bad idea then to check your answer by distributing. Now, I expect that most of you won't, but it's not a bad idea. Right, Mr. Valentine? Okay, let's look at one more. Negative 14x minus 12x squared. Now both of these have a negative. Right? So if I write out the prime factorization, we have a negative. 14 is 2 times 7 and times x. Negative 12x squared. Let's see, we have the negative first. What's the prime factorization of 12? Okay, 2 times 2, right, 2 times 6, which is 2 times 2 times 3. And then we have 2 x's. Right? So we circle what they have in common. They both have a negative and a 2, and they both have an x. So there's my greatest common factor. Negative 2x. Okay. Now, what goes inside the parentheses? Okay. We've got the 7 from the first one. But the question is, what goes between them? All right. Since we took the minus out, it's going to be a plus sign. Okay? And 2 times 3 times x is 6x. All right, so we can check it. Okay? Negative times a positive is a negative. Negative times a positive is a negative. Okay? So, all right, make sure that if they're both negative, you're going to take the negative out, so your sign in between them is going to be positive sign then. Okay, to express, write expressions for the length and width of a rectangle with the area expressed by a polynomial. You need to write the polynomial as a product. So you can write a polynomial as a product by factoring it. Right? So here, the area of a court for the game squash, anybody ever heard of squash?
No.
Okay. Right? Is 9x squared plus 6x square meters. Factor this polynomial to find possible expressions for the dimensions of the squash court. All right, so go ahead, factor that. All right, you just worked on one similar to that, so let's see if you can factor that one. So go ahead and factor that one. So, we factor it. The greatest common factor is 3x. Factor it, we get 3x times 3x plus 2. How do you find the area of a rectangle? How do you find the area of a rectangle? Length times width. Okay, so one of the dimensions of my squash court is going to be 3x. The other dimension of the squash court is going to be 3x plus 2. All right, because those are the two parts we're multiplying together. So the dimensions of our squash court then will be 3x meters on one side and 3x plus 2 meters on the other side. Yes, Avery. You can check it out later. Okay? All right? Okay, so you're doing good. For most of you, the prime factorization helps you. Okay? And so keep doing it. All right? Now, here we're going to look at something a little bit more complicated, but they're really not, okay? They look a little more complicated, but they're not that much more complicated. At least this step here isn't. Sometimes the greatest common factor of terms is a binomial. This greatest common factor is called a common binomial factor. You factor out a common binomial the same way you factor out a monomial factor. So, in this situation, right, our first term is 5 times x plus 2. So if I wrote the prime factorization of that, it would be 5 times x plus 2. All right, that whole thing. And the 3x times x plus 2 is 3 times x plus 2. All right. So, what do they have in common? They have x plus 2 in common. All right. So this is my greatest common factor. So we have x plus 2. So it's going to be a binomial is what's going to go out front, not just a monomial. And then you write what we have left. 5 and a plus 3x. So using the greatest common factor here also, and in this case, the greatest common factor is this whole expression. It's a binomial. All right? So look at the other one, letter B here. When it's written out like this, where you're factoring out a common binomial factor, it's actually easier, right? Because the greatest common factor is already shown for you. Okay. So in this case, the greatest common factor is just this b squared plus 1. So I'll write b squared plus 1 in parentheses, because that's my greatest common factor. All right, and then put my right parenthesis, or my left parenthesis. All right, what do we have left? Negative 2b here. And what's left here? If there's nothing there, then it's a 1. Okay, so negative 2b plus 1. Yes. It does not have to come first. I always write it first, but it does not have to come first. Okay. All right, so get another one. All right. How about this one then? What do these have in common? Okay, yep. Nothing in common, cannot be factored. Okay. So if they have nothing in common, they cannot be factored. All right, now, this is in preparation for if we have 4 terms, okay? If we have a situation with 4 terms and we want to factor it. So we're going to do factoring by what's called grouping. Right? So you may be able to factor a polynomial by grouping when it has 4 terms. The first thing we want to do always is make sure, okay, your number one thing here, okay, the number one thing we want, number one, is standard form. All right? The number one thing we want to do, first of all, is make sure it's in standard form. I'll bring up something else later in a minute, after standard form. All right. First thing, it's always got to be in standard form. Is this one in standard form? Okay, remember that's highest power to lowest power. So here we've got degree 4, degree 3, degree 1, degree 0. Okay, remember if it's just a constant, the degree is 0. And when we say we're going to factor by grouping, what we're going to do is we're going to take the first two pieces and the last two pieces. Okay? So we're going to look at these two together and these two together. And we're going to factor the greatest common factor for each group. All right? So what do 6h to the fourth and negative 4h cubed, what do they have in common? And so if you have to write these out, okay, that's fine, all right, to do it, all right. Let's see if we can do it without, all right. 6 and 4, what do they have in common? 2, okay, all right. And these have h to the third power, right? Okay. So we have 2h to the third power. And 6 divided by 2 is 3, and we have an h here. Right? And a minus and a 2. All right, because 4 divided by 2 is 2. And I already have my h to the third power. All right, how many of you want me to write the prime factorization and do it? Okay, all right. So now we have a plus sign here. So we look at the other group. Okay, Kimmy, what do 12h and 8 have in common? What do 12 and 8? What's the greatest factor, common factor of 12 and 8? Four. Yep, good. So we put 4 out front. 12 divided by 4 is 3. So we have 3 and an h, because we have this h here, right? And 8 divided by 4 is, right, so we have minus 2. Now, if you've done this right, most of the time, guess what's going to happen most of the time? Most of the time, these two are going to be the same, all right? Unless you made a mistake. All right? So if they're not the same, you should double check them to see if they are. All right, see if you made a mistake. Now, hey, there's my greatest, I have a greatest common factor again. So I write them, 3h minus 2. And what do I have left? 2h cubed plus 4. And there's my answer. All right. So it says factor by grouping. We take the first two terms, factor out the greatest common factor. Take the last two terms, factor the greatest common factor. All right. And then we have to factor the greatest common factor again. So we're really doing it twice. All right, let's look at another one. Now remember, our number one thing, standard form. So even if it's not in standard form, here, make sure it goes in standard form on your paper. Okay. Then number 2, factor in groups. Group 1 and group 2. Okay, 5 and 15, what do they got in common? Okay, 5. All right? Y to the 4th and y to the 3rd has how many y's in common?
3.
Okay, y cubed. So we have 5y cubed. All right? Jacob, what goes in the parentheses then?
Y, 1y to the first.
Okay? Then what?
And
What goes between them?
subtraction.
Okay, all right, y minus 3. All right, because I have to have y to the 4th power, so y cubed times y, and 5 times 3 is negative 15. All right, good. All right, Katie, what do the last two have in common? Do they have any numbers in common? Nope, because this is a 1 and that's a 3. Okay, how about any y's? We have y squared and y. Do they have a y in common? Okay, they have y to the 1st power. Right. Put our parentheses. And hopefully, y minus 3 is going to be what goes here, right? All right. So, hey, I need another y and a minus 3. Great. It worked. Okay. So now, oops. So they both have y minus 3. So that's now my greatest common factor. So we write that first. And then we write what's left. 5y cubed plus y. And as we get going a little bit more with this, we should have, the first thing we would do in the future would be to take a y out of everything to start with. Okay? All right. Well, I guess that's it. All right, so you do 4A. Do 4A.